In this video, I will provide you with a couple of different ways you can attach a stairway to a deck where you do not have a structural support. And you could always design the stairway so that you do have a structural support if that will work for your project. However, if it will not, and you have a situation like this, then you could either install a beam and maybe use some type of an inverted hanger at the other side, or set the beam on top of the post. And to do something like that, you would just simply miter the corner of this beam and this beam here, or look for another way to do that so that you would have a nice solid structural support for the stairway. And instead of a beam, you could always add another 2x or another piece of lumber that would be the same thickness as your deck joist. And then you could nail the stringers through the back of the joist and add either some 1x or some 2x, maybe a 2x4 connector board like we have here, to connect the two boards together to again provide you with some structural support, along with some building hardware. And instead of using lumber, you might be able to use some hardware, maybe some straps or even some thicker metal, 1/4 inch thick, that you might be able to use maybe one on each side or even just one on one side, where you would drill some holes through the lumber and use bolts to connect the two boards together. And of course, you could always use a smaller board. I see this a lot. And even though a structural engineer might not approve something like this, I've seen every type of assembly in this video, built a variety of different ways that seem to work just fine. However, I'm also not about to suggest that all of these connection methods in this video will work for every type of outdoor project. And of course, the old plywood connector, I have seen this plenty of times, even though it's my least favorite in this video, because if this plywood delaminates or comes apart within a few years or even a few decades, I would hate to be the person who's using the stairway when it does. And in this example here, you're simply going to nail the upper section of the plywood to your deck joist and the lower section to the stair stringers. And I did draw a piece of treated plywood in here if that's going to work better for your outdoor deck. And of course, we cannot forget the building hardware, even though these are just simply straps nailed to the back of the stair stringer and to the front of the deck. Some hardware manufacturers do provide special types of building hardware to solve this particular problem. So that also might be another suggested assembly method you could use. And I would also like to point out that if you only have a few steps, maybe 2 or 3, 4 or 5 at the most, then some of these methods might work a little better than if you have a longer stairway, or a stairway that's going to be located in a high traffic area. That's actually going to require a stronger structural connection. And that's what we're going to be looking at here, and the last one in this video. And all I'm going to do here is run the stair stringer under the deck joist if the deck joist isn't too large. This might not work with a 2x12. And of course, if you do have a 2x12, you might not have this problem anyway. So if you are using 2x6 or 2x8 deck joists, then you might be able to use this method here. And this is one that I like because you can use the exterior fascia board or the front of the deck, sides of the deck, as the last riser. You're going to be able to nail the joist into the stringers, toe nail the stringers into the double joist, or end nail the stringers from the other side before you install this joist here. In this video, I will provide you with another idea for building a safer set of stairs over an existing concrete stairway that might not be safe, or a stairway that might need smaller risers. And to save you some time and frustration, this is not a step-by-step instructional video. This is more or less a video that will provide you with an example of how something like this can be done. And in this example, we are going to be adding a sideboard here. And it's going to provide us with the additional structural strength we're going to need to hold everything together and be able to lift the stairway off of or put it over the old existing stairway. So we have a stairway here with 3 steps, and we wanted to add another step so that we could lower the height of each one of the risers to make it easier for possibly an older person to walk up and down a stairway. So we're just simply going to design the stairway like this. We're going to have a larger board. In our example here, this is a 2x10. And all of the lumber is treated. I will leave it up to you as to whether or not you need to use treated lumber or other materials. And I went ahead and added a gravel foundation here so that we could extend the lower step. However, this might need to be concrete. You might need to bite the bullet there to have something that will provide you with a little more support. So not too difficult to build. However, something like this is probably going to trap debris, dirt, sand, and if this becomes moist for a long period of time, it can rot the lumber. But that's the beauty of this stairway. If you build it to where you can lift the set of stairs off, then you're going to be able to clean these areas. Let's go ahead and take a look at the nailing. You can use nails or screws and put them wherever you possibly can to fasten everything together. And that would include whether or not you're going to create something permanent or have something that you'll be able to lift off so that you can clean the debris that will get captured under the stairway. And the debris usually accumulates from any gaps or cracks in the lumber, any knot holes that might have fallen out. So keep that in mind while you are building. And make sure that you nail or screw everything together, including the back of this board to your boards here. And if you are going to build it and then install it over the stairway, it wouldn't be a bad idea to check it in sections. So maybe build these 2 sections together and then set them over the existing stairway to see if everything's working. And it might not be a bad idea to use screws on the sides. Maybe only put a couple of screws in on the sides and then set everything in place to make sure that it is going to work and you don't need to make additional modifications. I mean, the last thing you want to do for a project like this, if you've never done something like this before, will be to firmly attach everything together using adhesives, whatever, and then find out that you made a mistake and your new stairway isn't simply going to slide over the existing one. Next up, let's go ahead and take a look at an example of how you can simply lift the stairway off and then grab a broom and remove all of the debris. And you might want to do this once a year, once every other year. And of course, if the gravel is not going to work out for you, then add a structural footing that will provide you with some better support and or allow you to permanently secure your new stairway to the existing one. And if the stairway doesn't seem secure, you set it over the existing one and it's wiggling a little bit while you're using it. It doesn't feel like it's going to be safe, then you might be able to use some screws or some type of building hardware to attach it to the existing stairway. Now, another thing I need to point out is that some stairways might require a longer last step. And if this is going to be a building code issue, then you won't be able to use this particular idea. Now, another thing I don't think I would be happy with, but you might be tempted to use, would be some type of a design like this to where you use a larger skirt board or sideboard to create this design. And I don't see a problem with this as long as you're going to install a guardrail on both sides, something that will not allow people to jump over the side of the stairway. Because something like this could be a trip hazard as somebody comes down the stairs and then wants to jump off of this step here or this one here, and then of course gets their foot caught and then face plants into the ground. Not a good thing. And definitely something to think about before and not after building something like this. In this video, I will provide you with the basic information you're going to need to add a landing at the bottom of a stairway. Now, the first thing you're going to need to do will be to remove the first riser in some cases, or the first tread. Now, you won't need to remove these all the time. However, in our example, we are going to remove them and measure the height of the stringer that sits on top of the treated lumber. And if yours is not sitting on top of treated lumber, you can simply grab a piece of treated lumber, butt it up against the stairway, and then measure the distance. And in this example here, we have 5 1/4 inches. And that will be the height of our floor joist. So we're going to need to cut a 2x6 that is usually 5 1/2 inches tall down to 5 1/4 inches, as long as we're going to be using a full 1.5 inch piece of lumber for our sill plates. Next thing, let's go ahead and draw the perimeter of the landing. And of course, your design can be different. Then we're going to cut our base framing plates, or the plates that our 5 1/4 inch tall lumber will be sitting on. Now, you can fasten these to concrete with some type of a wedge anchor, framing anchor like this one, that will require you to drill a hole in the concrete. Or you can also use some type of epoxy and all threads. And in some cases, you might be able to get away with using a shot and a pin. This is a type of nail that can be driven into the concrete with a tool that can usually be purchased fairly inexpensive or rented from your local rental yard. And if you are going to be attaching this to a wood framed floor, you can usually use nails or screws and even put some type of an adhesive underneath the framing plate. And it wouldn't be a bad idea to position all of the pins or the framing anchors in a location where they will not interfere with your rim joist or your floor joist. And to give you a better idea of what I'm talking about, let's go ahead and install the rim joist on each side. And if for whatever reason you need to notch any of the framing components for the floor joist or the rim joist here, that's usually not going to be that big of a deal. But you can see here where all of the pins are located in an area where they are not going to be underneath any of the other joist or the rim joist. So if you can avoid that, make sure that you do. And you can fasten the joist to the framing plates with a toenail or an angled nail, usually a 16D. And I will leave it up to you whether you use a common or a sinker nail. And let's not forget that you might need to check with your local building department to verify whether or not you can actually make this modification to your property, as I try to mention in most of my videos. And of course, you can end nail the joist through the ledger with 16D nails also. I usually like to install 3 for 2x6 or 2x8, and then 4 for a 2x10 or a 2x12 joist. And if for whatever reason you're using a 2x4, 2 nails should work for that. And of course, the rim joist can be toe-nailed, about 16-inch on center spacing for the nails to attach it to the framing plates. And after you have secured all of the framing, you can go ahead and install the floor sheathing. And in our case here, we are using the same thickness, 3/4 of an inch thick sheathing, the same thickness as our treads. If you are going to use materials with different thicknesses, make sure that you adjust accordingly. For example, if I was going to use 1 1/8 material, I would need to lower this another 3/8 of an inch to prevent riser variations in the stairway or different height steps. And another thing you might consider doing will be to put an overhang in the area that will be used to step down off of the platform onto the floor. And that would look something like this. The same overhang that we have here will be the one that we are using on the stairway. 1 inch overhang for the stair steps, 1 inch for the landing. And you don't need to put this on the landing if you don't want to. However, the step down will usually look better if it matches the stairs. And obviously you will not need it in any area that will be up against a wall or a section of the landing that you will not be using to step down off of the landing. So if you're going to be able to step down off the landing in this direction and in this direction here, then you might consider using a 1-inch overhang all the way around the deck. Another thing you might consider doing will be to bring the landing out to where it lines up with either the first step or the front of a riser, if this will work better for your design instead of coming back a little bit and then over. And of course, consider making the landing a little shorter. If this landing was about 1 inch shorter, we wouldn't have this small piece here. However, that won't work out all the time, and you might need to make adjustments to the sheathing or to the joist. And of course, we can change the direction of the floor sheathing if that's going to work better for us along with the floor joist. And you can always add 1 or more of the base framing plates if you want to make the floor a little stronger. And I've actually done something like this when using 2x4 joist, if that might work better for your project. And for those of you who have noticed, we have cut the ends of the stringer off so that we could butt the joist up against the stringer. And again, another idea that you can use if that's going to work better. In this video, I'm going to provide you with what I would assume to be an easier way to build a stairway that's going to have a miter design like this one here, where it does not go from point to point to point, in the same way that you would have a standard miter do. So we have a 90-degree angle on both of the designs, except we're going to move the miter over a little bit. And that's going to look something like this for a stairway that might be easier to build if you go from point to point to create a stairway with different sized stair steps. So we have 11 inches, and then we have about 17 inches over here. And if we built a stairway like this, we could run a stringer at an angle here. The stair stringer itself could be used to support the edges of the stair treads where the miter connects together. But that's not going to be the case on the other design, where the miters will be offset. And I'm not even going to suggest that you build this. However, for those of you who are, I'm going to try and simplify things. So again, you can see here where the miters are offset and still at a 45-degree angle. However, this is not going to allow us to use a straight stringer. So what I would suggest would be to position the angled stringer at a 45-degree angle to pick up at least one of the miters. But again, this isn't going to be required either. And if necessary, you can always change the angle of the stringer or add more than one center stringer and one stair stringer connecting into it. You might need to install another stringer over here, depending upon the maximum on-center stringer spacing for your tread materials. So we won't need to install any blocking here. However, we will need to install some blocking for the next step. And we're simply going to use a block here that's going to connect to another block, and then use 2 blocks here for the last mitered step. And again, you can get as creative as you want here. You can install the blocks differently, and you could even extend the length of this block all the way back to the front of the decking. So just keep in mind that you don't need to follow my example 100%, and you can get a little creative with your design. So again, the mitered angle for the stair treads where they're going to connect together now have some type of structural support for the stairway. And if you're going to build a longer stairway, might require additional structural support, stronger stair stringers, stronger stair treads, and additional bracing. In this video, I will walk you through the process of laying out a 6-step winder section of a stairway. And to do this in this example, we're going to start with a 6 foot by 6 foot square that you can lay out. And the first method might not be necessary, but I'm going to show it to you anyway because this might be helpful for you. And in that method, we're going to take a 2 foot radius. You can change it and make it larger or smaller if it's going to work better for your project. And then we're simply going to divide this into 6 units. Or you can divide it into 3 units on each side of a diagonal line that will connect from corner to corner. And I'm not going to go into much detail on this because I think I've created an easier method and one that will not require you to do a lot of math. And that would simply be to measure over the distances that I have here for your 6 foot square, even if your stairway is only going to be 3 foot wide. And this method should work just fine when measuring out a variety of different stairway lengths or stairway sizes. And if you notice, this measurement here is the same as this one. This measurement here is the same as this one. And this one will be the same as this one. And for those of you who cannot see it, this measurement here is 1 foot 7 5/16 inches. This one here is 1 foot 10 1/4 inches. And this one here is 2 foot 6 7/16 inches. And after you have laid out these measurements, you can connect the straight lines from those measurements back to the center or corner of our square box. And then we are going to take a 6-inch square, and you can just do this with a framing square. You don't need to make a separate square for this. And then we're simply going to slide it over until we have it lining up with this point right here. And again, this can be done with a framing square, just simply lining up the framing square with the 6-inch measurement there. And I do have other videos on that at our website for laying out a variety of different types of winders that I would suggest watching also if this doesn't make sense. And then once you have this mark here, you can simply create a straight line up to this point right here where it intersects into this line here. And then square off of that and go back here, or simply measure the distance down here and then measure the distance up here and then square off of this line here until it connects and meets right here. And then you're simply going to pull off of this line here a measurement of 3 feet or whatever size you're going to need for the width of your stairway to provide you with the desired layout you're going to need. So this one right here is 3 feet, and we're coming off of this point square to create a square inside of our winder stairway. And if I want to make it wider than 3 feet, then all I need to do is extend these lines outward a little further and then move these lines over. And before I do that, I just kind of wanted to point out here that most building codes require a 6-inch minimum distance here. And since that is the minimum distance and they can be larger, you're probably not going to have a problem with these measurements here. However, if you are, you can always change this to a curve to create an equal measurement all the way around for each individual step. And if we wanted to make the stairway 2 foot longer for a total of 5 feet, we can just simply move this line over around the perimeter like we did here to create a 5 foot wide winder type stairway with 6 steps. And hopefully that makes sense. And again, I think you can use the measurements that I have here for the 6 foot square along with the instructions in this video to lay out a stairway with this type of design. In this video, I will provide you with a way that you might be able to use to figure out the overall total rise in a stairway that you cannot just simply grab a measuring tape and measure from the upper level to the lower level because you might have other obstacles in the way preventing it. So let's go ahead and jump into this. The first thing you can do will be to simply grab a level and draw some level lines around the walls if this will work for you. I'm not about to suggest that something like this will work all the time, because you don't want to have a line going all the way around your wall. And if that's the case, you don't want a line going around the entire wall. You might be fine with using a level and then just making a mark at the corner, a small mark that you might be able to remove. And I've even made marks like this with a knife, just a little teeny slit that most people are never going to see. And if you need to use a straight edge, a straight board, because your level isn't long enough, then you can always use something like that also. Straight edge or a long board or a longer level. And again, you're going to end up doing the same thing, putting a mark in the other corner. And of course, from this point here, we will grab another straight edge and the level, and then go ahead and make another mark. And of course, this mark right here will be the mark we're going to use to figure out the total rise, or the difference between the lower level and the upper level. And of course, that method will work if you don't have carpeting. If you have carpeting, it could create another problem. And you might even have a difficult time figuring out the exact total rise, even if you use this method here. So what I'm suggesting here is that you create some type of a component that you can attach to the carpeting, something that will provide you with a firm and secure attachment. And to do this, you could grab a scrap piece of plywood and then screw it into a 2x4 to create some type of a platform like this that can also be screwed and attached to the flooring. And I'll leave it up to you as to how many screws you use. And usually screws can go through the carpeting without creating any problems. However, if this is going to create a problem for you, then I don't suggest using this method. And of course, all you need to do is have the 2x4s a little taller than the top of a landing or the next location that you're going to use, so that you can level across to create the first section of the total rise. And of course, this mark can be anywhere here that is lower than the top of this 2x4 or this particular board. And you can always set the level on top of this board also. And of course, the main thing we're trying to do is create level sections that we can measure later. So after we have created a level line here with our level, we can simply mark this 2x4 to create our first leg or our first measurement line, and then simply work our way up the stairway. Like I said, you can put the level on top of it, or I could have this a little bit lower, just as long as I'm creating level sections that I will be able to measure later to figure out the overall total rise. And again, with carpeting and padding, you could end up with a small variation when figuring out the total rise. And of course, all we're going to do here is measure from here to here, and then from here to here, and then from this point here to the top of the carpeting, and then add each one of these measurements together to figure out the total rise. And if you don't like either one of those ideas, you can create a water level and simply hold one end of the water level up, even or flush with the top of the flooring, and then simply work your way over to the other side where the water level can be marked, and then allowing you to measure from this point to figure out the overall total rise for your stairway. That can be used later to figure out the individual riser heights for each step. And in my opinion, if you're looking for accuracy, something like this is probably going to provide you with the best method, especially if your levels are not perfectly level. So keep that in mind also. Check your levels to make sure they are working correctly before using them and finding out that you're a quarter of an inch, a half inch, or even an inch off when trying to figure the total rise for your stairway. In this video, I will provide you with a method you can use. Keep in mind, it is not the only method that you can use to raise a stairway. However, it is one method you can use if you have lumber that is rotted underneath your stair stringers, underneath the bottom of your stairway, and it's sitting on top of a wood frame deck. And in order to do that, all you need to do is build something like this, something that you could use to raise the bottom. And I'm providing you with two different situations here. If you have a deck that goes all the way across, you can just use this method on both sides. And something like this will simply attach to the stairway. You're going to attach a board like this to the stringers, and this could always go on the inside of the stairway if that will work better for you. And we're also going to attach some type of a support board to this 2x4, and this can be a 2x4 if your stairway is not very big. If not, you might want to use something larger, 2x6, 2x8, 2x10. And we're going to do the same thing over here. We're going to attach this board to this one, this board to this one, and this board to the other side of the stringer, so that the bottom of each side can be raised enough to where we can slide another board underneath these boards here. And it's usually not going to require a lot to raise a small stairway. I've actually lifted them up before and put a small piece of plywood underneath the main support board. However, if you need a little more strength, grab a jack, raise one side, and then put your shim material underneath the support board, then move it over to the other side, and then raise it a little bit so that you can do the same thing by installing the shim. And I don't know why you would need to raise this over 3/4 of an inch. However, you might need to, depending upon how difficult it will be to make the repairs or to remove and replace any damaged materials. And if you need to, you might be able to leave the entire stairway intact and then cut at the bottom, cut at the top, and then lift the stairway out and set it aside, then make the repairs if that's going to be easier for you. Now, the reason why I don't want you to raise it too much is because we could end up with a gap over here. If you raise it, then it's going to be tight at this point here. However, this could separate, and if it separates enough, when you go to lower it back down, you could pull the stringer away from the head out or the top of the floor framing. And in our example here, we've only raised it 1/4 of an inch, just high enough so that we could remove the damaged decking board along with the damaged lumber in the stringer. You can cut a notch out like this, or you can just simply cut this section of the stringer off if you still have enough support on this side to structurally support the entire stairway. And you can always do the deck repair first. Repair the decking and then lower the stair stringers back and then reattach them to the decking. Then you can go ahead and make the stair stringer repair. And this is actually the order I would go in to make this type of a repair. So after you've removed the damage, you can go ahead and replace it with a new board. And that might look something like this, where you attach another block on the other side. And this block can also be used to nail or screw the stair treads into if for whatever reason the top of this board is damaged. So here is another video request from one of our viewers, and in it we will be providing you with some design ideas, not construction assembly ideas, for anyone who might be dealing with an angle, something that is not going to be 90 degrees at the top of your stairway. And of course, in this example here, we have a stairway that is going to come 90 degrees off of the floor. And the stairway, treads, everything. So here we have a standard construction assembly and design. That is not going to be the case if we move this wall and the stairway 22.5 degrees. And the problem I see with this particular design is the fact that the steps will not be the same size. And before building something like this, make sure that you would be allowed to build it in your area. Check with your local building authorities and building codes, because I don't think you would be able to just simply fill in this area here to create your last step. However, I would also like to point out that some building code officials allow for variations like this under certain special circumstances. And if yours falls into that category, then you'd be allowed to build it. I also don't think you would be allowed to build something like this because you're not going to have the minimum distance required for your landing or your step. And most steps require a minimum distance between 9 and 11 inches. Now, something like this might work because you now have a landing at the top. It will work if you have the minimum measurement, minimum distance required for the depth of the landing, and that's usually going to be 36 inches. It's got to be 36 inches or larger, and you might not have the room to build a stairway like this. It will depend on if you can move the stairway out a little further. And of course, something like this probably won't work either, but by reshaping the wall framing, you could actually create the 90-degree angles that we need to do something like this. So we would simply add another step to the stairway to where we have a landing that would be flush or even with the upper floor. And in a situation like this, the door could either swing in or out. However, this wouldn't be the case if you were to build it to where the last step was going to be here, because most building codes don't allow for doors to swing over the stairway. It can swing over a landing. It just can't swing over the stairway. And of course, that would look something like this if you had a wall on each side. And I believe that was the example that the individual who asked this question originally had. They had a situation like this. And in my opinion, if you can possibly remodel this area and you have enough room for a stairway like this, then this might solve your problem. And of course, the last suggestion that I have would be to redesign the stairway. And that, of course, will depend upon the design of your project. Here is another question that one of our viewers had. They wanted to know what the maximum angle could be for a sloping riser. And according to one of our popular building code books, it is 30 degrees. I will put a link to this particular building code. I'll provide you with a reference number and the building code book it came out of in the video description area. So 30 degrees, and that will be from the bottom of the nosing. And in this example here, the farthest protruding point forward that would represent our nosing would be right here. We could take our 30-degree angle from this point here. However, in this example here, we would need to lower that a little bit. If we had a nosing that looked like this, we would need to come from the bottom of it. And if we look at the measurement here, we're about 2 11/16 inches away from the vertical measurement coming off of the front of the stair step. And in this one here, we're about 4 1/16 inches with a 7-inch rise and a 10-inch tread depth. And of course, this measurement will get longer if the risers are taller and will become smaller as the risers decrease in height. And I don't think that the length or depth of the tread is going to affect this at all, as long as each one of the treads are the same size for each step in the flight of stairs. And of course, the most common angle you're going to find, and I've built hundreds of stairways like this, is going to be around 8 degrees. And that's going to be a 1-inch undercut or a 1-inch increase in depth of the stair tread due to the angle of the riser on each one of the steps in that particular flight of stairs. Here is another interesting question from one of our viewers, and something that I always thought about myself. And even though I don't know if I can provide you with the exact interpretation of this, I am going to provide you with what I found in one of the building code books about exactly how far one of these steps can slope. And to make things as easy as I possibly can, I'm going to start with a 4-foot wide stair tread, or something that is 48 inches, because the maximum slope is 1 unit per 48, or a ratio of 1 to 48. and that's 1/4 of an inch per foot. And to make things as easy as I possibly can going in the other direction, I am going to make each step 12 inches in depth. And of course, in this example here, we have a stairway that is level and square in each direction, suggesting that each step has the same riser height and tread depth, along with the width of 48 inches. So let's go ahead and slope this baby 1 inch. So again, a unit of 1 inch in 48 inches is the maximum distance a stairway tread can slope. And of course, now would be a good time to point out that even though you might be able to slope your stair steps, that a stairway like this won't meet the maximum riser variations of 3/8 of an inch per flight of stairs. So if I lower this an inch, I'm going to have 6 inches here, 7 inches here, and 7 inches on the other side, 7 inches up at the top, creating a problem for our riser variations. Now I do have more information about that at our website in the building code section. So check that out if you are going to be looking for more information. So again, a stairway with this particular design won't work because of the riser variations. And in our next example, we're going to slope the stairway to the right, again, 1/4 of an inch per foot. And something like this might have a problem at the bottom, where we have a low riser again of 6 inches and 7 inches going around the rest of the stairway. However, there is a building code that might allow this to work, so I'm not going to rule this one out. However, something like this will if we take and slope each step in this direction, and we often do this when installing waterproofing, some type of a waterproof coating over an exterior stairway to allow the water to drain off of the stairway and not accumulate in any spot on the stairway to create a problem for people using the steps when or shortly after it rains. So again, something like this should work just fine according to this particular building code. Now, what if we take one step and slope it 1/4 of an inch per foot while keeping the rest of the steps level for this particular design? And I don't see a problem with this, because if we slope this 1/4 of an inch per foot, then we're still going to have a 7-inch riser, 7-inch riser, and a 6 3/4 inch riser. And even though this particular stairway might be approved by your local building department, it's not going to be a safe stairway to use. You could see how it could offset someone's balance and create some type of a trip hazard. And of course, here's another example of a stairway that won't be meeting local building codes because of the riser variations. So even though I might be allowed to slope this 1/4 of an inch in this direction, and slope this one 1/4 of an inch in this direction, and slope this one here 1/4 of an inch per foot in this direction, you can see again where we're going to have problems with the maximum riser variations of 3/8 of an inch per flight of stairs. And hopefully this makes sense. I would also like to point out that I have never installed a set of stairs with any step or landing sloping in this direction or in this direction, so sloping from right to left or from left to right. However, I have built plenty of stairways where the steps have sloped in this direction here and no more than 1/4 of an inch to allow water to drain off of the stairs if there is some type of waterproof coating that is going to be installed over them on an exterior stairway. Here is another stair building code you should familiarize yourself with, and I will put the reference number to that particular building code in the video description box so you can go check it out. And of course, the building code that I am referring to will have something to do with the curve or a bevel that might be located on the front of a stair tread. And don't be surprised if you come across any building products, especially products for masonry construction, that are used for stair treads when they shouldn't be. Now, the building code refers to a 9/16 of an inch maximum radius. So the radius would be the measurement from the center of a circle to the edge of the circle or the perimeter of the circle and would look something like this. So this is the maximum. It can be smaller, it cannot be larger, unless your local building authorities, people who provide you with the building code information in your area, suggest otherwise. So always check with them before building your stairs to make sure that you can or cannot use the information in some of these videos. And of course, here is the maximum curvature. Let's go ahead and take a look at the maximum bevel. And since the bevel was not stated in the same way as the curvature, I'm going to go out on a limb here and assume that they're talking about this measurement here that cannot be longer than a 1/2 inch. And since they are referring to a bevel, I would imagine that you could shape this bevel in a variety of different ways with a variety of different angles, as long as this measurement here is not more than a 1/2 inch. And of course that bevel would look something like this. And no, I would not suggest using a curve and then a bevel and then a curve. Use the same design for each one of your steps to avoid confusion. And as I mentioned earlier in the video, I came across a radius that was probably about 2 inches when watching another video about someone building stairs in what appeared to be England, where of course the building codes might be different. So again, a bevel not longer than a 1/2 inch, a curve with a radius that is not going to be more than 9/16 of an inch. Here is another video that is inspired by some of the videos that I have seen on the internet, one especially. And even though I will not be providing you with any details about the video, it has inspired me to provide you, the viewer, with something you might not want to do. And that would be to use individual footings or small blocks, bricks, you name it, underneath your stringers. However, I would also like to say that I do understand why someone might do this, especially if your ground freezes in the wintertime and causes frost heaving or forces sections of your concrete footings to rise or raise above the ground. However, if I was going to build something like this, I still don't think I would use small individual footings that don't go into the ground deep enough. And I think the project I saw, it looked like they poured the footings after they set the stair stringers, but I'm not sure. Here we have a set of stairs where everything is nice and straight. And then maybe in a few years, you end up with some of the stringers and the footings either sinking into the ground or raising above it, creating a situation where you no longer have, in my opinion, a safe set of stairs. And this problem is going to get worse the further you space the stringers apart. So here we have them spaced about 16 inches on center. Here they're spaced 24 inches on center. And depending upon the size of the footing, you could end up with them tilting to one side as the soil erodes from underneath one side of the footing. However, I can't end the video without providing you with some type of hope, and that would be if you're going to use a 2x, maybe a 2x6 or a 2x8 for your risers, and you firmly attach them to your stair stringers, then these can actually act as structural supports. And even if you do end up with a couple of the footings sinking into the soil, or rising, the stringers could actually provide you with enough structural support to prevent the stairway from deforming too much. So keep that in mind if you are going to just simply place a few blocks or pavers underneath your stair stringers because you're trying to save a few dollars or you're dealing with another problem that I didn't mention in this video. And that problem might actually be the fact that you just don't have enough money. You need to save a few dollars here and there. Then I get it. Just be prepared for problems in the future. And maybe a helpful solution to that would be to use screws for everything so that you can unscrew some of the treads and risers so that you can access these areas for easier repairs in the future. In this video, I will provide you with an example of something that could create a headroom problem if you have a set of stairs above another set of stairs, and you're already dealing with something that is at the minimum or close to the minimum headroom height allowed by your local building codes. And this is actually something that was brought to my attention by someone who was removing and replacing a stairway above another stairway that went into a basement. And it's really not too difficult to understand how you could affect the headroom height. Let's go ahead and provide you with an example of what the headroom height would be for this stairway. And that's usually going to be a vertical measurement from the front of the stair treads, going from the farthest projection forward off the front of the stair nosing or stair step all the way to the top of the ceiling, or in this case, the bottom of the stairway. So let's pretend like this measurement here, this area represents the minimum stair headroom height for a stairway. And if our new stairway is going to be moved forward, we're actually going to increase the height of the headroom. And in this example, we moved it backwards, or in this direction here, and reducing the height of our headroom clearance. However, if we leave this one in its current spot and move this one in this direction, we're going to have more headroom. And the opposite would hold true if we move the lower stairway forward in this direction. However, this is not what originally inspired this video, because the individual was going to build a stairway that was going to be wider. And as you can see here in this example, this would reduce the headroom height. And in our example here, I increased this distance by 4 inches, and it's going to affect our headroom height by 5 inches. And I would imagine this is going to be a big problem because most people are going to be replacing the old housed stair stringer type stairways. And I'm guessing they built millions of these types of stairways that went into your basement, and millions more that were above the stairway in the basement. Next up, let's go ahead and take a look at what you're probably going to be dealing with. Smaller steps and taller risers. And you're probably not going to have the room to make them longer. However, if you do, and this seems to be a big problem, I get a lot of viewers requesting information on this. And I've already made quite a few videos explaining it a variety of different ways. This is just another one that I hope will make a little more sense, because most of the time, the individuals who are asking me how to solve this problem want to install a longer stairway, a stairway with longer steps and shorter risers. And hopefully by now you know exactly what I'm going to say next. We're going to end up with a headroom problem here unless you replace the upper stairway and create the same stairway or something that will provide you with a safe headroom ceiling height for your project. So again, if we move the stairways in different directions, or if we make them longer or shorter, or make them thicker and fatter, we could end up reducing our headroom ceiling height for the stairway, which in turn would create building code problems and make the stairway difficult for taller people to walk up and down. If you work in construction long enough, you are going to hear terms used by other builders, architects, engineers, and construction workers that you might not be familiar with, and these are a couple of them. If you are building a set of stairs or talking to an architect or engineer over the phone, and they use the term carriage or horse in a sentence that might sound something like this: we are going to need to use 2x12 for our stair horses, or this set of stairs will require 4 stair carriages. Then at least you won't have to look this up in a dictionary, because all they are referring to is the stringer. And even though you're probably not going to run into this very often in your area, there's a good chance you're going to run into this while watching other videos or talking to other people who live in different parts of the world about building stairs and construction. This video will be the first in a series I'm planning on doing to provide viewers with product information. This is something that has been requested for quite some time, probably since the day I started my channel. So let's go ahead with the first one, and that will be to provide you with a variety of different adhesives you might be able to use when attaching wood to wood in the situation where you have a tread connecting to a stringer. Or if you have a situation where you have a wood finished tread, like an oak tread, that needs to attach to plywood or OSB. And the first thing I need to point out is that if you are dealing with lumber that is going to shrink or expand and contract, like most construction standard lumber, plywood and OSB might not fall into this category or might not expand and contract as much as construction standard lumber. I've seen 2x12s shrink from 11.5 inches to 11.125 inches. And if you're using 2x12 for your stair stringers, which is probably the most common lumber used, you could end up with a gap between the tread and the stringer. And if you're using glue, you're using an adhesive that is not flexible or allows for movement, then it will actually separate and either stick to the stringer or the tread, providing you with a gap between either the adhesive and the tread or the adhesive and the stringer. Because as the stringer contracts or shrinks, it's going to pull away from the tread. So again, if you're using construction adhesive that is not elastic or flexible, then there's a good chance you're going to end up with your stairs squeaking. So what I would recommend would be to find a product with polyurethane in it. Now, I could swear that I used to use a product with polybutylene in it. However, since I couldn't find any products with polybutylene in it, then I have to figure out that I probably made a mistake and that it was actually polyurethane that I was referring to. Now, what I used to use was a window and door sealant, and they do not sell this product anymore. And it worked great. We used to use it on all of our floors and our stairs. And since that product is no longer available, I will not be able to provide you with its product information. However, I will list a few products in the video description area or in the comment area, along with a little more product information when it becomes available. So make sure that you check out our video description area if you're looking for more information about adhesives that will reduce stair squeaking that should work for your project. Here's a problem that one of our viewers ran into, and I understand it's not going to be a problem that most of us are going to be dealing with, and that will be the walk line. The walk line is usually going to be 12 inches from the inside of the stairway. This would be a curved or a winder stairway. And since this particular stairway has steps that are exactly the same size on the inside, on the walk line, and on the outside, then we're not going to have any problems with the building codes. So again, that would be for a stairway like this, a curved stairway with the same sized treads on each step. However, that's probably not going to be the case on a stairway like this. I'm not about to suggest that you can't design a stairway that will have the same walk line throughout the inside of a stairway like this. However, you're not going to have it on the other side, suggesting that this is a stairway that is probably not going to be approved by most building departments, where you're not allowed to have more than 3/8 of an inch variation in the walk line. And hopefully this makes sense. However, if it doesn't, because you're not wrapping your mind around the fact that people aren't going to walk along this side of the stairway all the time, they're going to be walking up this side also. Right here we have a big problem between this step and this step, and I really don't see any way around it to create a stairway that would work with this particular layout. In this video, we will take a look at what I've noticed to be the biggest problem when covering stair stringers with deck tape and other exterior stair building projects, and that's the fact that they somehow cut it into 1.5-inch strips or buy 1.5-inch wide deck tape and use it for 1.5-inch wide stair stringers. And what happens with this is that the water can actually enter into the area underneath the deck tape and on top of the stair stringer. So to fix this, all we need to do is simply use larger pieces that will fold over the sides. So for example, a 2-inch piece of deck tape is probably going to work better for an 1.5-inch wide piece of lumber. And in this example here, I'm just providing you with what it would look like on one side of the stair stringer. You're going to need to have it go over both sides. And it wouldn't be a bad idea to also go over the front of the stair stringer. And even though this won't prevent water from absorbing into the side of the stair stringers, by folding it over, it will allow for the water to stay away from the top of the stair stringers. Next up, let's go ahead and put some caulking at the back. We've covered the sides and the front, but we could still have water absorbing in from the back here. So maybe some caulking, some type of a sealant might work. You can put the sealant on and then put the tape on, or put the tape on and then put the sealant on, whatever you think is going to work best for your project. You don't want to seal the entire top of the stair stringer and then allow water to seep in from the back here, especially if your goal is to keep as much water off of the top horizontal sections of the stair stringers as possible. And last on our list, besides covering the entire stair stringer, would be to cover the risers with your deck tape. Just keep in mind that water leaking down will be able to get behind these areas. It won't be as easy to keep the water out of the vertical sections as it will be to keep it out of the horizontal sections. And I know some of you are going to suggest using treated lumber. Go for it if that's going to work better for you. And don't forget that you can paint or use other wood sealers to prolong the life of your stair stringers also.